Hi, my name is Kero, and I work for a game development studio called Team Intuition. And today, I'm going to show you how to make this effect. Before we begin, there are some things you should know. This tutorial uses the Unity 3D game engine, and you'll need version 2018.3, 2019.3, or newer. If you haven't already, I will walk you through starting a new project using the scriptable render pipeline and installing the visual effects graph. My intention is to keep this tutorial accessible to beginners. So let's get started. If you haven't already downloaded the Unity Hub, you can install it by going to this link, store.unity.com/download-NUO. Once on the page, click on the blue Start Here button, and be sure and read the conditions. There are certain cases you should be aware of. Unity Hub is a launcher for the projects you'll make in Unity. However, to get started, you'll need a license and you'll need to download a version of Unity into the Hub. To get a free Unity license, you can perform the following steps. To install the latest version of Unity directly from the Hub, you can click on the Installs tab, click the Add button, select the version of Unity that you want to download, then click on Next, and then click on Done. It may take some time to complete the download. Next, we'll create a project using the URP. A quick sidebar.
The URP stands for Universal Render Pipeline and is Unity's way of allowing you greater scriptable control over graphics and visuals in your game. Rendering usually handles things like lighting, shadows, pixel colors, and is essential for seeing visuals on a screen.
To create a project using the URP, go to the Projects tab, click on New, click on Universal Render Pipeline, name your project, change the location if you want, and then click Create. Welcome to the Unity engine. When you load up your HDRP or URP project, you'll be greeted with this demo screen. There is quite a bit here. So in order to constrain the length of this tutorial, I'll try to only tell you what is directly relevant or related. To use the VFX or Visual Effect Graph, we need to install it using the Package Manager. Note that if you chose HDRP instead of URP, the VFX graph would already be included. Now, to open the Package Manager, go to the Window menu on the top left and click on Package Manager. Once in the Package Manager, Ensure Packages says Unity Registry, and then we can search for the Visual Effect Graph. Click here and install. After installing, you may need to restart Unity. A quick walkthrough. Unity has modular windows, but by default you'll find the hierarchy window on the left. The hierarchy is for listing the game objects in your scene. Whenever you click on a game object, information about it will appear in the inspector on the right. The inspector contains all sorts of useful information, from tweaking object settings to adding and removing components. Your project window is down below, next to your console tab. You can click back and forth between them as needed. The project window contains files and assets added to your project, and the console contains print statements executed by your script. If you've added any, it will also display errors. Last but not least, we have your scene and game view. Now, the game view will be the view that the player sees, and you can manipulate this by positioning the camera object in the hierarchy. The scene view represents the entire world currently, what is both in and beyond the player's line of sight, and you can use it to position elements in your 2D or 3D world. Next, to navigate the scene view, it is highly recommended you use a mouse. While hovering over the scene view, hold the right mouse button to turn your field of vision. You can also scroll the mouse wheel to zoom in or zoom out, or hold down the mouse wheel to pan your view. Note, if you don't have a mouse, you can use this hand-shaped button in the top left, which will allow you to use this via left click. You can also reset your zoom level by focusing on an object and pressing the F key. To do this, simply click on an object in your hierarchy or scene view, hover over the scene view, and press the F key. Next, we'll cover how to create a game object. Everything in the hierarchy is a game object. A game object stores data and components for a particular object. To create a cube game object in the scene, for example, right-click in the hierarchy, go to 3D Objects and Cube. Note that the cube was created both in the scene view and in the hierarchy. Remember, you can focus the scene camera on the cube by selecting it in the hierarchy, then hovering over the scene view and pressing the F key. Right now, this cube is sitting in space. It isn't doing much yet, but we can interact with it. After selecting it, we can move, rotate, and scale this cube using these three buttons on the top left. Move, rotate, scale. Control Z to undo. We can also perform these same operations with more precision using the transform component in the inspector. Each of these collapsible gray lines in the inspector represents a different component. But right now, we'll just focus on transform. Using the values here, we can adjust the individual X, Y, and Z position, rotation, and scale. Right now, let's just make a long flat cube. We'll use this as our floor. Next, we'll create a visual effect atop that floor. Right-click in the hierarchy, go to Visual Effects, and then Visual Effect. Note that if this option doesn't appear, you may have needed to restart Unity after installing the visual effect graph. This will create a game object with an empty visual effect component attached to it. The reason why it is empty is because it doesn't have a VFX asset attached. So, in order to create one, right-click in your project window, go to Create, then go to Visual Effects, and Visual Effects Graph. Don't forget to name your effect. I think I'll name it Fire Mouse. Next, we can click on that visual effect game object in the hierarchy and drag and drop that Fire Mouse VFX asset into the slot. The first thing you might find is that your effect was created away from the floor. But that should be an easy thing to fix. Simply select the item and use the previous transform tool, which is this one, or the transform component to move it onto the floor. Before we proceed, now is a good time to learn how to save your scene in Unity to avoid losing it. To save your scene, simply go to File, and then Save or Save As. Finally, we can get into the visual effect graph. Next, we'll cover how to create a game object. Everything in the hierarchy is a game object. A game object stores data and components for a particular object. To create a cube game object in the scene, for example, right-click in the hierarchy, go to 3D Objects and Cube. Note that the cube was created both in the scene view and in the hierarchy. Remember, you can focus the scene camera on the cube by selecting it in the hierarchy, then hovering over the scene view and pressing the F key. Right now, this cube is sitting in space. It isn't doing much yet, but we can interact with it. After selecting it, we can move, rotate, and scale this cube using these 3 buttons on the top left. Move, rotate, scale. Control Z to undo. We can also perform these same operations with more precision using the transform component in the inspector. Each of these collapsible gray lines in the inspector represents a different component. But right now, we'll just focus on transform. Using the values here, we can adjust the individual X, Y, and Z position, rotation, and scale. Right now, let's just make a long flat cube. We'll use this as our floor. Next, we'll create a visual effect atop that floor. Right-click in the hierarchy, go to Visual Effects, and then Visual Effect. Note that if this option doesn't appear, you may have needed to restart Unity after installing the visual effect graph. This will create a game object with an empty visual effect component attached to it. The reason why it is empty is because it doesn't have a VFX asset attached. So, in order to create one, right-click in your project window, go to Create, then go to Visual Effects, and Visual Effects Graph. Don't forget to name your effect. I think I'll name it Fire Mouse. Next, we can click on that visual effect game object in the hierarchy and drag and drop that Fire Mouse VFX asset into the slot. The first thing you might find is that your effect was created away from the floor. But that should be an easy thing to fix. Simply select the item and use the previous transform tool, which is this one, or the transform component to move it onto the floor. Before we proceed, now is a good time to learn how to save your scene in Unity to avoid losing it. To save your scene, simply go to File, and then Save or Save As. Finally, we can get into the visual effect graph. Now, in simple terms, the VFX graph is basically Unity's new particle system. A particle, also in simple terms, is usually a small 2D graphic effect used to add visual flair to an action or effect, at least within the field of game development. Particle physics, however, may use a different definition. Particles are used in many things, from shooting a spell, to weapon slashes, and even heavy landing. To improve our particles, from these awkward 2D circles to something more distinctive, we can open a visual effect by double-clicking it in the project window. It will pop out this VFX editing window, which we can either leave popped out, or we can dock it by drag and dropping. I'll dock mine here, next to the inspector. This editor window allows us to change the setting of a particular set of visual effects, from the image, speed, direction, color, velocity, lifetime, shape, and so much more. For example, this default system is spawning 16 particles per cycle in the spawn block. I can increase that value like this, 32, 100, or even 1000. But I have to ensure the maximum capacity in the initialized block is raised accordingly. Note the difference over here. Also, you'll note several blocks here. There are spawn, initialize, update, and output. The spawn block controls the spawn setting, including timing and rate of spawning. The initialize block controls start values for when the particle is first spawned. The update block allows for changing values every time the particle updates, and the output block determines some of the final settings, such as which direction the particle should face, should it be billboarded, which means always facing the camera. You can change the particle image, and you can control whether the color should shift over the lifetime of the particle. Let's get started making this look like fire. Now, I'm not really one for build-up, so attached to this lecture, courtesy of Unity, you can find a link to a fire sprite sheet. Download and drag that into your project window to continue. Okay, so with your sprite sheet in your assets or project folder, you want to drag the texture onto the main texture slot of the output block. So drag this right here. The main texture is responsible for the default look of your particle. However, right now it's displaying the entire sprite sheet rather than a single flame or a quickly shifting animation, which is our goal here. To get it to display just a single flame, let's go over here and set the UV mode to Flipbook or Flipbook Blend. And let's set the flipbook size to match the number of rows in the image. I count, in the actual texture itself, 8 on the x-axis and 4 on the y-axis. So let's go 8 and 4. Now, it displays individual fire sprites, one per particle. Better. However, we still have to fix two things: the dark background and the lack of animation. To fix the dark background, we need to change the blending mode from alpha to additive. From alpha to additive. Which basically suggests that instead of blending the particle according to its transparency value, we draw the visible colors atop other colors in the scene, additively. These will remove the background. Excellent. Next, with these settings established to play the full animation, we need to add a flipbook player to the update block. Remember the update block. Now press the space bar and type in flip book, enter, and it will add that, and voila. Although we're not quite done. We can play around with the specific settings for controlling timing and speed, but in general, 8 on the x-axis times 4 on the y-axis is 32, which means setting this number to 32 will play the entire animation at least once before the particle vanishes, though we may want a slower flame. As the artist here, that's up to your discretion. Play around with it. Figure out what looks best for your goal. I think I'll go with 16 for now. Next, we'll refine the effect. Fire's main particle usually stays in the same zone, rather than floating upwards. So let's tweak some settings to enhance its verisimilitude, its similarity to the real thing. To tweak this, let's just go here and set the y-axis to 0. The set velocity random node basically allows you to add a random amount of velocity between two values or vectors to the particle when you first spawn it. Do you see how each flame goes out in a random direction? That's because it's drawing from this range of numbers to this range of numbers, and it generates a random value in between per particle. Next, what we'd like to do is get the flame to drop in world space rather than local. Right now, it's in local space, which means the particles move along with the game object. World space would mean that when the particles drop, they're actually left behind or in the wake of the game object. To change this effect to world space, let's go to the initialize block over here and toggle world. Click over here, press the spacebar, set, position, down, pick this one, and then from here, we'll need a few other things. First off, we need a vector 3, which will produce a 0, 0, 0 vector, and then we want to change the space from local to world. Right now, this L right here denotes that this vector, the 0 vector, is in local space. So when we change it to world space using this node and output it, it will determine where the fire is. And so now, magically, oops, wrong item. It will leave fire in its wake as we move it. By the way, to turn off the white lantern effect, you can click the Gizmos button toggle above the scene view. Cool. Next, we only want to spawn these flame particles while the transform is moving, or while the game object is moving, rather than just having it spawn stationarily. So, we'll disable constant spawn over here. Now left click here, spacebar, and we'll add a new node called spawn over distance. Now, spawn over distance spawns particles only when the game object is moving, or when it's moved a certain minimum amount. In order to detect that amount, we'll link the change space node, or at least its output, to the node's position input. So left click here on this yellow dot and drag it right here. This is how it knows when it's moving. Next, in spawn, originally we had it spawning about 16-ish, but right now we have 10. We could change this to 16, but it might be more useful to make this an external variable. That means instead of having to come to this graph, we can edit it from the inspector directly instead. It'll appear over here. So let's do that now. Left click and drag over here, We'll change this to a float. And we'll right-click and choose Convert to Exposed Property. Now, what this does is in the blackboard at the top right, if you click it, we see the properties or variables, depending on how you want to look at them, appearing here. If we click it over here, we can name it rate, and it will rechange it over there. And now the default value is 10. Let's change it back to 16. Okay. Now, if we go to the inspector and click on the visual cube, rate now appears. So we can change it from the inspector without returning to the visual effect graph. Of note, if you haven't already set the capacity to 1000, make sure that you do here, since this number must be higher than the number of particles you wish to display on screen at any given moment. If we run out, we can't create more until the old ones disappear. Also, let's change the flame rate to 30 for now. I feel like this feels more flamey, but without overdoing it. Next, we can turn the constant spawn rate back on, but let's change the rate to 4, just so we have an idea of where the object is sitting. After that, we'll add an add node right here and connect the change space into its A slot, and the output we'll put into set position. The reason we're doing this is so we can create an offset, vector 3, that will become an exposed property in the blackboard so that we can control its position from the inspector. If we switch over to the inspector, we now have an offset. We can use that to manipulate the position of the fire if we need it. Now, we're going to add an event node. Right-click, create node, event. Now, event nodes represent events we can call from a C# script. When called, they can activate a system within the VFX graph. In this case, we'll use our events to start and stop the flow of main particles. So drag from here to the start portion. And let's also add a second event and drag it to the stop portion. The events often have names, so here we'll rename it to start. And here we'll rename it to stop. Note that once you attach an event like this to the start, the system will no longer start automatically unless that event name, start, is also set under initial event name. However, if we need to test an event, we can always press the buttons on the event themselves. Another important note, whenever you see an asterisk up here in the name of the visual effect, it means that it hasn't been saved yet. And that part is important because you don't want to lose your work. So in order to save it, simply click the Save button. Voila! And of course, don't forget to save your scene. Either Control S or go to File in the top left and save. In the next section, we're going to begin C# scripting for additional control over the visual effect we've made. To create a new C# script, right-click in your project window and then go to Create in C# script. Let's name this Click Control. Basically, what this script is going to do is allow us to control where the visual effect is based on where we click with the mouse once we start the game. Now, the first thing we should do after creating the script is go to our visual effect in the hierarchy and then drag the script onto it. Next, we need to open the script for editing. To do that, simply double-click on the script and it will open up your editor. Now for me, I use Notepad++, but yours might pop up something like Mono Develop or Visual Studio. Either is fine as long as you're able to compile and execute your code. Now, here's where we start scripting. As a programming instructor, I understand it can get both complex and overwhelming for necromancers, newcomers, very quickly. And there's a lot to learn, so I've attached some notes for you to pause and read at your leisure. However, I'll do my best to keep it simple here and only discuss what's essential. Each word, each curly bracket is important, and structure in when coding is very important, except for comments, which are basically personal notes for you to read. So, to ensure this code works optimally, you must pay close attention. Writing or spelling something incorrectly will result in an error, and the code will not run, nor will the scene play until the error has been fixed. A syntax error is when you've written something wrong, so the code in Unity won't compile. A semantics error is when it compiles, but it doesn't do what you want it to do. Let's avoid both, and let's get started. Now the first thing we'll need is a new import statement using unityengine.vfx. This allows us to access the visual effect graph code. From there, we'll need two new variables, visual effect, and the variable name will be VFX, and camera, and the variable name will be cam. Think of variables like cups that hold data of specific types. Next, inside the start method, what we'll need is to use that variable to hold a value. And the value we're going to hold is a component, so get component, left and right angle brackets, left and right parentheses, semicolon. And the component we're grabbing is a visual effect that is attached to the same game object that this script is attached to. So if we click over here in visual effect, this click control script is attached to this visual effect, and so is this visual effect component. So this is the component that we're getting with this line of code. Next, we need to do the same thing with camera, or cam in this case. So cam equals camera.main. And so when we say camera.main, it finds the static camera class and returns the main camera in the scene, which in this case is this one right here. Next, the update method. Now, since the update runs multiple times per second, in fact once per frame, ideally, it's the perfect place to detect user input. Here, I've added some extra comments in green if you'd like a bit more understanding on the coding structures we're using. Now, using the update method to detect user input allows us to execute code when the player activates a button or mouse. An if statement allows us to decide when to run certain code blocks. Here, on line 42, we're detecting the first frame that the user presses the left mouse button down. And if they do press it, then we want to send a start event to the visual effects graph. Here, we make another if check for when the key is released. And if so, we call the stop event instead. This stops the VFX graph when we release the mouse button. These are called semicolons, by the way, and are placed at the end of a line of code to indicate that that's where the line stops. It doesn't go after if statements, or curly brackets usually, but it will come after most singular lines of code or variables. One more thing, these debug.log statements here allow you to print to your console in the Unity engine when certain sections of code are run. This is a basic yet incredibly useful tool for understanding, debugging, and fixing your code. Let's test it before we continue. Save your script using Control S or File, Save, then we can switch back to Unity. Here, an important note, when naming the events here, start or stop, ensure that there are no spaces at the end of the name or before it starts. Otherwise, your code will expect those same spaces when you call the event through your script. Ensure your graph is saved so you know the latest version of it is being used. And check your console tab for errors. If there are any errors with your script, they will show up here in red, and you must fix them before you can continue. Next, we have multiple tabs here, but what we want right now is to see the scene view and the game view side by side. So click on Scene, then left click and hold on Game, and drag it to the right until the square appears, then release to dock it. Now we have scene and game view side by side. Next, if our goal is to test our script and whether it works, assuming we're free of errors, what we need to do next is adjust the camera. So in order to do that, consider that we have two views. On the left, we have the scene view, which is the world, and on the right, we have the game view, which is what happens when you press play. To adjust the camera in game view, we can click on the main camera in the hierarchy, then go to its transform in the inspector, and raise the value on the y-axis. Now as I do this, watch what happens in game view. Pull it back a little bit, and let's rotate it a little bit on the y-axis so we can look at it from an angle. Okay, so now maybe not the perfect view, but this is roughly how it's going to look when we actually start the game. Remember, game view, scene view. Maximize and play. Let's give it a try. So here we see that the fire start's already active. If I left click and then release it, it'll stop. And if I left click and hold again, it'll start. Stop and start. And then release again. One other thing you might not have noticed, in the console, because of the debug.logs, I know exactly when I started holding a button and then let it go. This is why debug statements are useful. They help you prove that your code is running and test that the timing is working as you expected. Okay, let's return to the script and add the mouse button hold functionality. At the bottom of the else statement, we're going to add an additional else if block. So else if, parentheses, and curly brackets, input dot get key keycode dot mouse 0. The only difference here is we use get key for hold detection instead of get key up for key release or get key down for key press. Inside the if statement's curly brackets, we'll need to make a ray cast into the scene. You can think of a ray as an invisible beam with a starting location and a direction to move in. And cam.screenPointToRay converts a position on our screen into a ray directed further into the screen. So when we say ray mouse beam equals cam.screenPointToRay, parentheses, semicolon, input.mouse position, you understand that we're using the mouse position and the camera position to create a ray into the game world. Now that we've made the ray, the next thing we want to do is make a ray cast. On line 53, if physics.raycast, parentheses, mouse beam, comma, out, raycast, hit info, 100, followed by curly brackets for the if statement. This is when we actually fire the ray. Again, it's still invisible, so this firing is only for detection, not visuals. And by placing the raycast statement inside of an if statement, it will only run the code inside of that if statement if the raycast hits. When we fire the ray, we store information about the collision in a variable called hitInfo, which we're defining right here using these additional keywords. And if it hits something, we'll grab the point of impact as a vector3 and move our VFX game object to that location. This last number here, 100, it just controls how far we can fire the ray. Right now, it's set to a maximum of 100 units, though it will stop sooner if it collides with something. To move a location, inside the if statement, we'll put vector3 position equals hitInfo.point and transform.position equals position, grabbing hit point from ray, moving the VFX. Let's do a quick test of what we've got so far. So if I left click and hold, it moves the VFX to the location of the click, and if I move the mouse while holding it down, it will follow the mouse. And if I let it go, it'll stop. Now, say that I don't like the offset, I can always come here, change this to 0, and do it again. But now it's too far in the ground. Let's try that one more time. Let's try 0.3. Oh yeah, that looks good.